Hi, welcome to the Tommy Flowers Network and the Smart Connected Manufacturing Making It Happen seminars. My name's Steve Carter and I'm a senior technical specialist for smart factories, cyber physical systems at Rolls-Royce. And today I'm going to talk to you about smart factories and taking advantage of telecommunications infrastructure and advancements. So today what we're going to learn today. So we're just going to talk about a quick introduction. Who is Rolls-Royce? Who we are? How we operate? And we're going to go through, as I said, talking about smart factories and how you can take some of the challenges and how you can take some of the benefits, take the full benefits of the advantages of telecommunications within a modern factory, and followed by some Q&A session with yourselves. So welcomes. So thank you very much for the Tommy Flowers Network for asking me to present today in this series of smart connected manufacturing sessions. So I'm Steve Carter from Rolls-Royce, and I work in the central innovation hub concerning smart factories and cyber physical systems. My background is in robotics automation for the last 20 years, looking at both technology development, both from a manufacturing perspective, robotics and systems, and also designing through to smart factories. And I've also been involved in a number of external bodies in terms of standards regarding automation, communications, data and systems. Okay. So who are we? So it's a quick overview of who we are and how we operate as Rolls-Royce. Rolls-Royce is obviously a global company. We are one of the world's leading technology companies, creating power and propulsion systems for use in land, sea and in air. Our vision is pioneering the power that matters. We pioneer cutting-edge technologies that deliver the cleanest and safest, most competitive solutions to meeting the planet's vital power needs. And that's a really strong technology statement, and also very relevant for the challenges for environmental and sustainability, which we're very much focused on for net zero in our strategy. So some of our strategy themes include electrification. Obviously, probably most people associate us with traditional gas turbine jet engines from an aero perspective, but we're very much focused on electrification, e-mobility, so flying taxis and electrical hybrid propulsion systems for both for larger aircraft we're developing in-house, and also for as I say, e-mobility type sector as well. We've got some good offerings there, and power generation as well. Digitalisation is key, both for our manufacturing, always has been for the last 20 years, very much focused on the digital thread in terms of through our design into manufacturing, and also then into our end products as well, which we'll talk a bit more about in a minute. And also looking at the growing needs for competitive clean energy. We're very much a leader in respect of looking at small modular reactors for nuclear power stations, through to smart grid, microgrids, and in-core and battery storage systems as well. So that's a key aspect for all our product portfolio as well. So as I say, we're kind of divided into three main business units called civil aerospace, defence and power systems. And overall we have like 50,000 people employed globally, 18,000 engineers, very focused on STEM type subjects, both for encouraging it in schools and obviously with apprenticeships and also for graduates, and with presence in over 50 countries over the world. One of the key things that we've focused on a number of years ago, and most people in different sectors have kind of tried to kind of follow this, is like power as you go, as opposed to power by the hour, should I say, as opposed to a fixed payment contract on buying an engine. And this was something that was based on the ability to be able to contextualize data and also connectivity of that data in terms of the lifecycle, to have confidence, the reliability, and that's something that is filtering through now into the consumer world, where it's like people are looking at more now like paid by the hour, maybe in terms of domestic goods or services, or even the likes of cars in the future. So that's something that we've been a leading light on. And that's all about and the vision of that, really, what we've delivered as a product in our intelligent engine, is about connected, contextually aware, and comprehending data insights. Again, involves data analytics at edge, and also back at base in terms of telemetry data, of which obviously connectivity is key. And some of the other things that we're looking at in terms of what we're pioneering and our use of is the adoption of AI, very much in terms of, let's say, our intelligent engines, through to our manufacturing, through to our on-wing inspection systems, and also even in maritime in terms of AI being used for command scenarios in terms of chief engineer sort of for ships, autonomous ships. And again, connectivity and data all come hand in hand with those, as it does with electrification sector and also SMRs for sustainability for power stations as well. So smart factories. So the theme today we're kind of focused on was just kind of a bit of a sort of so much a lessons learned type thing, but kind of an open sort of things of considerations, because everybody's at different levels of maturity in terms of their adoption of the latest technologies. Some people might think it's the latest, or some people might have been using it for a number of years. So this is kind of sort of just provided a bit of food for thought for people that might be at different kind of positions in terms of their maturity. So how to take advantage of telecommunications, wireless communications, and also in a factory, and also some of the challenges and considerations. So when you look at Industry 4, Industry 4 is a buzzword. We live in a digital world. It could mean a number of things to people. Digital twin is a buzzword. But you've really got to understand the meaning behind that. Plant intelligence, edge analytics, MES, PLM, they're kind of industry, kind of things that have been around for a number of years. Internet of Things, robotics, collaborative robots. Data interoperability and standards is key, as is skills. We'll talk about that more in a bit. And connectivity, whether that's wired connectivity, traditional, or whether we're talking about more wireless type of communications, which is obviously there's many different types that could be used: Bluetooth, RFID, near field, Wi-Fi, 5G, Wi-Fi 5, 6, etc. It's a fast-moving pace. But for me, cyber, Industry 4.0 is cyber physical systems, or is it physical cyber systems? Because even though we live in a digital age, you still need to understand the context of the original and actual artifact in question, whether that's a machine or a part. So sometimes I always kind of also term it physical cyber systems as well. But the reality is it's simply a system of systems, and that system of systems thinking is key in terms of integrated viewpoint. So when we talk about, say, for robotics, this is probably a good example. I think some other co-presenters from other fields outside of Rolls-Royce are presenting during these days, talking about different fields. I think one of them is robotics. Robotics is very close to me. We took a traditional robotics in the 1960s, very clumsy, very heavy, dirty robots, really, in terms of hydraulic driven, through to the modern 6-axis type robots. And even collaborative robots. So people now working with robots with reduced safety in terms of traditional fence line, but now they've obviously more software built into robots, sensors built into the robots, and even actually in some cases remotely controlled robots in some cases, not from the factory but even further afield is possible, with the likes of the latest communications with 5G, for instance, which there's been a few public case studies of, not to do with Rolls-Royce, but just as an example of what is the art of the possible. And obviously there's a lot of low-cost robots now. There's more domestic type robots as well. We see more robots now in the likes of possibly in our homes, like robot vacuum cleaners, through to robot lawnmowers, for instance, or even looking at the likes of remote parcel delivery, not particularly drone, but obviously that's another form of communications, but we'll start talking about delivery of parcels on the street, where robots, or similar to like these Amazon ones, where on the streets. But again, connectivity is key for that. And always a benchmark for me is Ocado in terms of their technologies that they've developed in the grocery sector. Warehouses the size of 3 football pitches. In some cases, I think the largest 4G private network in Europe, with controlled by AI. I mean, that's a phenomenal integration of successful technologies, not without challenges, I'm sure, as well. And then obviously you've got likes of Rolls-Royce as well, exploring quite publicly about using micro robots for inspection and peripheral repairs, possibly in engines as well. So, but again, robotics is just one theme, but connectivity is key, and even more so when you look at these new emerging applications of robotics. So when you start talking about in industrial space, you start talking about, obviously, we talk about Industry 3.0, the art of automation robotics. I've termed this 3.99, so the latest before Industry 4. Industry 3.99 is still available, but traditionally, large companies would have adopted an ISO standard called ISO 95, and it looks like the different levels of communications within a factory, from an enterprise perspective down to the sensors and the raw process at the bottom. Very much kind of wired type infrastructure with network switches, centralized hierarchy of control, I suppose. And that goes for PCs on the shop floor through to robotics, automation, or other machines. Data is obviously transmitted to the machine, to instructions, and data is collected from the machine and sent to various systems for continuous improvement, and also for historical reference as well, in terms of meeting our company own needs and also regulatory needs for traceability. But when you start talking about Industry 4, okay, it starts to sort of take to a new level, really, of level of connectivity. There's many kind of models of looking at Industry 4, but one of them is RAMI, the Reference Architecture Industry 4.0. Doesn't replace ISO 95, but it starts talking about things and connectivity and the wider world. And when you start talking about Industry 4, we're talking about a lot more connectivity of devices, wireless type sensors, autonomous vehicles, robots, etc., asset tracking, and all this sort of type of technologies. And when you start talking about that, that's where kind of integration and communications is really, really key. To visualize the data, make decisions more quickly, do analytics more quickly, and even run real-time simulations perhaps in some cases, and even like having more agile configurable networks, more plug and play, as opposed to before maybe more fixed traditional wired network technology. Software defined networks is an area there which has got good potential in factories, as cybersecurity and information security is paramount and always has been, and obviously as technology evolves, it enables more parts as possible, but obviously as it's a sector that kind of grows by every day, isn't it, in terms of cybersecurity, in terms of its meaningfulness and gravitas importance. So today we're talking, saying a bit more focused now for the last few minutes, but how do you take advantage of these telecommunications infrastructure enhancements? And this was something I did for a similar event in Singapore. So, a question was raised, how do you consider, infrastructure with wireless communications where, you've got to take advantage where, without, product life cycle can be very quick. How do you avoid major investments, etc., unnecessarily for obsolescence? So, in a factory, you could consider the adoption routes and considerations for telecoms. You've got primary infrastructure. Do you want to have a completely wireless infrastructure? Would you have a secondary infrastructure? Are we talking about this peripheral type stuff? So you might have segregation from the shop floor networks and have kind of your facilities management separate, for instance, from a ecosystem or from a security perspective, or are you talking about additional remote sensors which aren't part of a wired, to say, straight network? They're part of remote sensors for asset tracking or condition monitoring, for instance. So these are considerations or scenarios. When considering an application, you should consider, if you've got low frequency data, high frequency data, is it a time sensitive network required, and what is it high volume or low volume associated with that sensor and that process, and where that data is going. And these are all key solutions really to help you to understand the requirements, which I'll talk about more in a minute, and also from the end solutions. So challenges and opportunities. Some of the products do have a short lifetime in hardware and software, and evolution and their supportability. Industrial spaces don't typically change their networks every 5 minutes. As we've already seen in consumer market, more and more people realizing that certain more IoT devices in the consumer space have a very much faster pace obsolescence or even supportability, which causes a technical debt. And that's that's the thing in an industry that doesn't typically change network technology very quickly. Clearly, there's a business case for doing so that that drives in some cases, or just obsolescence. So that's a key consideration. And like I say, everybody's on different levels of maturity. So if you were looking at 5G, you would need to really consider kind of your data routing. Are you using a public public 5G network, or are you going to be using a hybrid route, for instance, or private? And certainly for certain companies, they wouldn't pick a public 5G network. They would want to have a private network and control of where the data is sent and controlled as per the endpoints of the devices that they're connected to. And that's a real consideration of where you are and what you want to do and how that integrates to your current infrastructure. Cybersecurity, as paramount before, you need to consider the implication of kind of any wireless devices, really, in terms of does it cause any more vulnerabilities or security? How does it fit into the security model of your network, your device in question, the data traffic, and the systems management of that kind of network and endpoint devices, particularly considering the data of those as well. Particularly in regulatory sectors, we need to consider kind of how that data is controlled and where it's stored, and in terms of the encryption associated with that at any point in the end-to-end process. Other key important things are what are all the business real requirements from all the people that need to support it. It's all very easy to get very focused on the technology solution, but the business requirements from all people that have got associated with this technologies that you might be looking at is key. And that will and some assets might be some of the connectivity devices that might be bolt-ons, or they might be you actually change the control systems to actually get more enhancements directly in the machine, as opposed to having a kind of a secondary feedback system. And some connectivity type projects with sensors, for instance, are going to be less low risk or compared to others for safety critical. And these are important considerations to understand where what solutions you need from a systems engineering requirement from all the different people. Some things will be more agile to deploy, that might direct you in different types of technologies, mesh technologies, Wi-Fi or Wi-Fi 6 or Bluetooth, for instance, if it's sensor technology, and then benchmark what the solutions that you need. And obviously that drives your cost that's going to be associated with the solution to purchase and install and integrate as well. Integration is the key thing, and the lifecycle costs. As is a data alignment as well, in terms of data quality alignment. You've got different timestamps going on from all these different types of systems or networks. If you've got multiple solutions, you've got to be able to have a kind of a unified timestamp to align those data to make it meaningful. And it's also important to understand the IT and OT ecosystem associated to supporting this, whether that's in the OT space or the IT space. You need to also understand the network performance requirements for your process, and if it's going to cause any safety critical issues, if it's the SLA doesn't meet the needs, and that's conversely it drives what the SLA needs to be in terms of availability and latency for your application using wired or wireless communications, but even more so in the wireless space. And also understanding the industrial shop floor is a noisy place, and I don't mean from a noise in terms of what we can hear, but from electrical noise perspective, and these can have all factors that can affect your Wi-Fi and also, for instance, 4G or 5G network performance, and conversely the impact of them on any peripheral equipment. But paramount, one of the key things is OT and IT skills and IT/OT skills, understanding through the adoption of technology to ensure that the solution or solutions are truly successful, which we all want, and everybody wants to gain the return of investment on that. But these are only a handful of considerations to, clearly there's large benefits, big benefits for return on investment from a business perspective and insights, and for having extra data, high speed data, making better decisions. But you need to understand this kind of wrap of different technologies and approaches. And standards are really important in this space, and there's many standards out there talking about this, but one of an interesting one, that's something that BSI created, a PAS document 7040 a couple of years ago, and that looked at kind of the trustworthy of precision sensors in a manufacturing space, and that kind of goes through some of this topography really of kind of considerations. So just to conclude, really, just in a smart factory is really big benefits from having wireless communications and any telecommunications, for instance. But key focus areas for success in a cyber physical or system of systems is the integration, system engineering focus in terms of how these integrate successfully and the considerations to get there. I hope you enjoyed that. I hope that provides some insights and some of the opportunities and challenges, and how you can turn those negative items into positives, really, by those areas I've highlighted. If you have any questions, please feel free to ask now. Thank you.